Hello everyone. In this video, double integration is to be discussed. Now here we are going to look at double integral as a whole. If we have any integral of this form, it's said to be double integral. Now one may ask, like, what's the use of double integral? Double integral helps us to find the area of a rectangle and also the area under a curve. You can also use double integral to find the volume under a region or the volume of a region. So here you are going to look at double integral, but first you have to get the understanding of what integration is. So if you are asked to find the integral of a function, let's say x5 plus 5x squared, to integrate this, what you do is that with integration you add 1 to the variable, to the power of the variable, and you divide by the power of the variable. So here our variable is x because we are integrating with respect to x. So to integrate this particular function, we add 1 to the power of the variable. So with the first one, we have x power 5. When we add 1 to the 5, we get 6. So for the first term, we have x power 6 divided by 6 plus, here we have x raised to the power 2. So when we add 1 to the power 2, we get 3. So then it becomes 5x cubed all over 3 plus c, the constant c. So now this becomes the integral of this particular function. So with double integral, it's done the same way, but just that here we have 2 dimensions. Do you understand? So let's take an example of double integral. So let's say we are given a function of 1, 2, 0, 3, 2 plus 2x y dx dy. The x dy is the same as dA. In some books, instead of using dx dy, they write dA. So here we are going to find the double integral of this particular question. So now, see here we have the x coming first, followed by the y. So what it means is that the limit for dx is 0, 3, and the limit for dy is 1, 2. So here we start with dx. You can start with either dx or dy. You can integrate this starting with x or starting with y. You get the same answer. So now here, looking at this particular question, we're going to start with dx. So we first integrate with respect to the x. So we have 0, 3, 2 plus 2xy dx dy. So now when you integrate this function with respect to x, so here we have only 2. So what it means is that there is an x there, but the x is raised to the power 0, and any variable, any number raised to the power 0 is 1. That's why we see only 2. So if we have x raised to the power 0, and from what I said earlier, when you're integrating, you add 1 to the power. So when you have x power 0 plus 1, you get what? X. So here we have 2x. The power is 1. If you divide by 1, you get the same 2x. Plus, here too you have 2. Here x is raised to the power 1. So when you add 1 to the power, you get what? 2. So you have x squared y. The power of x is 2, so then you divide by 2. And it's from 0 to 3. So 2 cancel 2 here. So here we first put in the upper limit, then minus the lower limit. So upper limit, we have 3 plus 3 square y minus 2. The lower limit is 0, so you have 2 into bracket 0 plus 0 square y dy. So this goes to 0. So here we have 6 plus 9y dy. So now we are done with the first integration. Now we are going to do the second integration to get our answer. So here we have 6 plus 9y. So with the first term, there is 6. And there's a y there, but the y is raised to the power 0. And any number raised to the power 0 is 1. That's why we have only 6 there. So when you add 1 to the power 0 of y, you get y. So you have 6y. And the power of y is 1. If you divide by 1, you get 6y plus 9. The power of y here is 1. So when you add 1 to the power, you get 2. So y square divided by 2. And it's from 1 to 2. So now we put in the upper limit and the lower limit. So our upper limit is 2 and the lower limit is 1. So you have 6 into bracket 2 plus 9 over 2 square minus that of the lower limit, 1 plus 9 over 1 square. So here you have 12. 2 cancel this, 18 minus, so you have 6, 9 on 2, which is, this will give you 30 minus, this is 12, 20 on 2. So you can 60, so you have 39 on 2. So this then becomes the answer for this particular question. Or when you get here, you can just use your calculator to punch this straight to get your final answer instead of working all these steps to get the answer. So this is the end of this particular lesson. But like I said, here I started with dx. One can start with dy, you still get the same answer. So you can start with either dx or dy, you still get the same answer. So this gives us the area. So this is considered to be the area of a rectangle, because you have, and when you have a rectangle, you have the limits. So this becomes one side of the rectangle, and this becomes another side of the rectangle. So when you have a double integration of this particular form, it gives us the area of a rectangle. So in our next video, we are going to look at the applications of double integration. Thank you.